is Sonigra, and today in the subject of mechanical drafting, we are going to discuss the solutions, the projections and sections of solids, and the solutions of various examples. And the objectives for today's discussion are like this. The first objective is to understand the concept of projections and sections of solids, to prepare the drawings for sections of solids, to solve the problems of various solids, and to draw the sectional views and true shape of the sections based on given conditions and given cutting planes. The first example continued from the last lecture which we skipped. We had solved the half example and remaining portion today we are going to solve. The data was given like this. A square pyramid of given dimensions is parallel to VP, its axis parallel to VP and inclined at 60 degree to HP. And we have to draw its projections such that the edge of the base inclined at 30 degree to VP and the apex is on HP. And it is also 40 mm away from the axis. So the solution of this problem is drawn up to this step from the last time. We continue that solution. First we had drawn this top view, a square in such a way that this side makes an angle of 30 degree with XY line, and another criteria is that this distance, the midpoint of this square and XY line should be maintained as 40 mm as is shown over here. So this distance is 40 mm and this angle is 30 degree. The side length of this square is given, that is 50 mm. From after that, this top view, we have drawn this front view, and then it is given that this square pyramid is resting on HP and its apex point is on HP. So we have to redraw this figure in such a way that this is an apex point which should remain on XY line. So O dash is on XY line. Then we have redrawn this solid in such a way that this axis makes an angle of 60 degree with horizontal plane. Now our objective is to find out this top view. So for that we name the points, say A, B, C, D, A dash, B dash, C dash, D dash, O and O dash respectively. Now rename all these points on this view as well. So A dash, B dash, C dash, D dash and O dash are here. Now to find out position of point A, let me take projections from A dash. So vertical line from point A dash, that would be like this, and horizontal line from point A, and that would be like this. And both these lines will meet at one point. It is somewhere here, and name that point. This is the point and that is point A. As it's a top view, dash mark should not be there, or we can extend A1. Now to locate the point of point B dash, from B dash draw a vertical line. It would be like this, and from B, this is here, from point B a horizontal line like this, and both these lines will meet at one point somewhere here. This is called as point B1. Now point C, with a similar exercise, vertical line from point C dash like this, and horizontal line from point C, that is projection line from point C like this, and both will meet at one point, and this is point C1. Similarly D dash point is here, so vertical line from point D dash and horizontal line from point D, that is projection line from top view of point D, it is somewhere here, that is point D1. So A, B, C, D, 4 points are there. Now point O dash is here, so from O dash draw a vertical line, from O draw horizontal line, both will meet at one point, that is point O1. So these are all the points that we have located. Now join all these points in sequence, and for that we have to check the visibility of the views and points. If you're looking from here, from top, then ABCD face would be fully visible to us as it is towards us. So join ABCD 4 points with the full line, say A1, B1, B1, C1, C1, D1, that would be like this. So this A1, B1, C1 and D1, 4 points should be joined with full line, and it's a visible line. Apex point O is here, so O to D1 is outside line, so it's a visible. O to B1 is also outside line, so it's visible. A1 point is visible to us, hence O1 A1 will also be visible, so it's like this. Now think about point C1. C1 O1 generator or that slant edge will not be visible, so that should be joined with the dotted line like this. So this dotted line represents the hidden edge O1 C1. This edge, if you look from top, this edge will not be visible, hence we have represented it with the dotted line. So this is the top view. You can name the views. This is front view, this is top view, and you can insert the dimensions in this figure like this. This is what we have drawn, and this height is say 140 millimeter. You write like this, height is 140 millimeter, and this is a square of 50. You can write like this, SQ50 means it's a square. And this angle, you have to insert this angle. As we know, that angle is 60 degree. You can write like this, and you can also represent its axis, this shown by this red color, that is the axis of this solid. Now how to locate the axis of this solid in top view? So for that, what should we do? From this point, axis in top view, in front view is here, so from this point draw a projection line, and axis point or apex point in top view is here, so from that point draw a horizontal line, that is projection line, and both will meet at one point somewhere here. So this is the midpoint of this solid, and through this midpoint, join this midpoint with this apex point, and this represents the axis of this solid in top view as well. So I hope the solution of this problem is clear to you. This is the solution. You can name the views. Now second problem, and the data is given like this. This we have solved. Problem number 2. A hexagonal pyramid, 20 mm side of base and 70 mm axis, has one of its corners on a base on VP and axis inclined at 45 degree to VP. Draw front view and top view of the solid. So here in this problem, hexagonal pyramid is given to us, and its one corner is on vertical plane and axis is 45 degree to VP. So first we assume that the axis is perpendicular to VP, and then first we draw its front view and top view, and after that we will draw its second step. So let me see one video clip for the solution of this problem.
Projection of solids, hexagonal pyramid. A hexagonal pyramid having 20 mm long has one of the corners of its base in the VP, and its axis is inclined at 45 degrees to the VP and is parallel to the HP. Draw the front view and the top view. Adjust the scale of the mini drafter so that it matches the horizontal line of the drawing sheet. Mark the XY line and the vertical plane VP above the XY line and the horizontal line HP below the XY line. Construct the hexagon with A' at extreme left or right for the base. Join O' to points A', B', C', D', E', and F' with thick lines. This drawing represents the top view of the slant edges of the hexagonal pyramid. Now project this to the top view. To draw the top view, locate the axis at a distance of 70 mm from the XY line. Mark the point as O'. Now join point O' to A, B, C, and D with thick lines. Also, join points A and D with a thick line. Now, tilt the top view such that the axis makes an inclination of 45 degrees with the XY line. Construct the top view such that the axis is on 45-degree line by taking approximate measurements from the first top view. Draw the projection lines from the top view and the first front view to obtain the final front view of the hexagonal pyramid. Intersection of projection lines of A and A dash represents A dash, B and B dash as B dash, C and C dash as C dash, D and D dash as D dash, E and E dash as E dash, and F and F dash as F dash. Now, join points B dash, C dash, D dash, E dash, and F dash to O dash. The lines A dash to B dash and A dash to F dash represent the hidden base edges. Mark the figure above the XY line as the front view and the figure below the XY line as the top view.
So these are the steps which we have followed. The first is to adjust the scale, then mark XY line, construct hexagon. Below XY line, project this in the top view, then tilt the top view such that the axis makes an angle of 45 degree with XY line. Draw the projection lines from front view and transfer to the top view and draw its top view. Now next problem, example number 3. The data is given like this. A cone is freely suspended from a point on the rim of its base so that the vertical plane containing the axis is inclined at 60 degree to VP. Draw the projections of the cone if the diameter of base of the cone is 100 mm and axis is 90 mm. So in this problem, let we think about the hints. A cone 100 by 90 is given. We should write the given data in a small segment so that it would be easier to redraw this problem. So first we insert the dimensions, cone 100 by 90, then vertical plane containing axis is at 60 degree to VP. First draw top view as a circle diameter 100 mm, then draw front view as a triangle having height 90 mm. Cone is freely suspended so that the line will pass through the CG of the cone. If we freely suspend any solid, then line of action from the suspension point will pass through its center of gravity, and that would be a vertical line. So locate center of gravity in the front view, and after that we will tilt that front view in such a way that the point of suspension and center of gravity becomes vertical line. So it would be like this. First of all, draw XY line that represents intersection of HP and VP. Draw circle below XY line having diameter 100 mm. Insert the dimension 500. Draw axis, horizontal axis and vertical axis of this cone, and from these endpoints draw projection lines, and at a height of 90 mm from XY line mark a point on its axis and draw a triangle like this. So this triangle represents the front view of this cone. Now we have to draw this solution. Until now it's clear to us. In any problem these steps would be alike in case of cone. Now, in as per the given data, what should we do? Here it is given that it is freely suspended from its rim. If we suspend this solid from its rim, it's freely hanged. So here we need to find out its center of gravity in front view. So this is the front view that we have drawn. Now locate its center of gravity in this front view. This is the axis. So how to locate its center of gravity? We know CG of a triangle is at a height of 2/3, but CG of this solid, as this is solid, so the CG will be at a distance of 1/4 of its height. So this height and this height, we know this total height of this solid is 190 millimeter. So this height would be 90 upon 4, that is 22.5 millimeter. 1/4 of its height would be center of gravity, and the CG will be somewhere here. So mark here a point CG and join that CG with this corner like this. You can name this CG as point G as CG, apex point O dash, G dash, here is point A or A dash. Right? Now we have to suspend this solid from this point A dash. We pick up this point in our hand. If you freely suspend, point A dash would be somewhere here. Let me name this point A dash somewhere here. Now if you freely suspend, this A dash G dash line will be perpendicular to our baseline or XY line. So first we have to redraw this A dash G dash in such a way that it becomes perpendicular to XY line. So transfer this distance or measure this distance A dash G dash and locate it over here. So G dash A dash G dash would be here. This distance and this distance both are similar. Now we have located 2 points, and by taking the distance from these two reference point or by measuring distance with the scale or by drawing arcs, we can transfer rest all points like this. O dash is here,